So switching means sending data from one place to another. Now there are two types. First one we call packet switching, meaning your message will be broken down into small chunks, or we call packets, and packets are free to go anywhere to reach the destination. So which means now in this case, if you see three different colors, the three different colors can take any place to reach the destination. So this is called packet switching. The other one is called circuit switching, meaning you have a physical connection between the sender and a receiver. The example is use of telephone network. So in traditional telephone networks, it was physical connection like this, connecting many circuits together, create a physical connection. So if you compare the two, circuit switching and then packet switching, what you need to remember is you don't have a physical link in packet switching, and circuit switching you have physical link, and the packets are independent, right? That means take different paths. The circuit switching also the same, it might take different path, but you have a dedicated line, not like in previous case, right? The next point that we were discussing is to talk about transport protocol in the internet, right? So there are many protocols we use when it comes to internet, especially in communication networks. But one of the things is transportation protocol. Now, the first question that we want to discuss is IP address. It's not enough to communicate between two computers, one host to another host. So that means in device communication, having IP address is not enough. IP address, we can identify particular computer, but not in application level. Because when it comes to internet, for example, multiple application connect to that at the same time. So we need to identify which, for example, application communicates, right? Now for that, we use what we call the port number. Now, I hope you remember the ports we discussed, physical ports. In physically, to connect peripheral devices to the computer, we have physical ports like USB and PS2 and so on. But this is what we call is logical ports, right? Now, for example, if you take the protocol SMTP, small mail transfer protocol, we call it, uses transport communication protocol. And the port is used is called 25. So there are various ports we can use, but these numbers are kind of a fixed, meaning that others may not use this because it might create confusion. But when it comes to mail communication, we are using port number 25. So likewise, hypertext transfer protocol, we call hypertext transfer protocol, especially when you communicate with web pages. So it also uses transportation control protocol in a network layer, and the port number is 80, right? So sometimes in web addresses you will see these numbers, like when you browse, maybe you can carefully see how this varies, especially when you access web pages. You will see that different these numbers are, you can see in the address. So similarly, HTTPS, hypertext transfer protocol, secure, especially when you make a secure communication, like you are connecting to a bank, right? Or you are making a purchase using a credit card, then the connection should be secure one. So it will use hypertext transfer protocol, but secure version, right? And for that, actually, they'll communicate with port number 443. Then finally, we have file transfer protocol, or in short, we say FTP. So FTP also uses TCP, and the port numbers varies. There are two, 20 and 21, right? And there are many others as well, like Telnet, IMAP, RDP, Secure Shell, DNS, and so on, right? So these are like some of the protocols that we have discussed, right? And the final thing that we have actually discussed is use of multiplexing. The idea of multiplexing is when you want to send multiple data in the single medium, right? So what happens is you have a n inputs. So multiplexer will take the n inputs and make it into a single channel, right? It's like you come to this point using let's say multiple cars, and here you put into a truck, and then truck will go through this like as a single unit. You will go through here, and when it comes to demultiplexer, it will actually take them out, like once you reach here, individual car take over, right? So this is easy sometimes multiplexing because that when you have traffics, you can limit the number of traffics here, right? So that's what we have discussed last time when it comes to, that is 6.8, right? And then the other things that we want to discuss, we discuss port numbers, we discuss what the multiplexing is, and I told you like there are two. Then we have to discuss UDP and TCP, right? So the idea of UDP is another protocol we call user datagram protocol, right? For example, this UDP is used some of the other protocols like DNS and SNMP, right? So usually used for what we call query-based communication, and it's not connection oriented. The meaning of this is, now usually when you have connection, so in UDP it's we will not have physical connection, right? So it's a part of what we call the TCP/IP, which especially when it comes to internet. Internet, we are using two main protocols, that is TCP and IP, right? So UDP, sometimes we known as stateless, right? So now we will not talk about like connections, right? We talk about this. There's no what we call here is not a connection oriented, meaning like you don't acknowledge sometimes. Now in previous ones, when you send a data from one point to another point, you wait for the acknowledgement. The other party will tell you whether they have received the data or not. In UDP, we don't have a mechanism like that, right? So the features, now if you we want to talk about some of the properties and the applications. So the properties of this, so when it comes to receiving side, data is not confirmed, right? And this is not suitable for reliable data connections, like if you want to send important data through the communication line. So this is not suitable, right? But this is suitable places like voice, video, because like sometimes you can lose some of the voice signal, but it's still you can manage, right? So remember, UDP is not suitable for the data transmission, especially for reliable data transmission. And then protocols such as DNS, DHCP, RIP, VoIP, these are some of them, connection with this protocol, right? And this is the speed. If you look at, the speed is very, very high, right? So there's no way to check the data, right? But this is suitable applications where you need very high speed, right? So for example, if you look at the application, online gaming, right, video conferencing, so they can use this UDP protocol. So that's the first one. Then the other one that we want to discuss is TCP, transport control protocol. So like in previous case, So again, TCP is very commonly used, and the difference between the UDP, it establishes a connection. Connection means every time when you send the data, you should get an acknowledgement, right? If you didn't get the acknowledgement mean the other party should tell whether they have received the data. If you get the acknowledgement only, you are going to send the data back again, right? So first of all, it's a connection based one, and it is suitable for reliable data transmission, and you get the confirmation. So these are like some of the very important ones. So let's write down, right, the ports. So we'll start with saying user datagram protocol. User datagram UDP. User datagram protocol. Right, let's write down. Right, let's write down. This protocol is a part of TCP IP protocol suite. When data sent using UDP protocol, when data is sent using UDP protocol, receiver will not acknowledge the receipt of. Therefore, it is it speeds up the communication between sender and receiver. we'll have a small picture for this one. So let me take a quality one. Right. So this is a small picture will demonstrate you how the communication happens. Now UDP use a datagram protocol. I told you when somebody requests data, sender is keep on sending data. There's no checking back. There's no acknowledgement. Acknowledgement means you are going to say that, okay, I have received the data. So because of that, this is very fast, right? UDP communication. But TCP, Transport Control Protocol, is connection based, like you establish a connection. So whenever you want to make the connection, so there'll be a signal sending, and then you will be acknowledging this. So whenever you send the data, the receiver has to inform back whether they have received the data or not, which is, you will see that quite slow compared to UDP, right? So let's take down this, and after that we'll continue. Problem with this communication, UDP, I told you, there's no synchronization, no acknowledgement. The problem is if you lost something, when you send data from sender to receiver, if you lost something, you will not get it again. So this will not suitable for reliable connections. So the applications that you can use is voice over IP, voice over IP. That means you can have we call VoIP. That means voice services we can use through the internet, no problem. Then DNS search, online gaming, music streaming, right? These are some of the applications we use to send data through UDP protocol. Right. The next one that we want to discuss is TCP. So the next one is we call transmission control protocol, or we call TCP. Right. So let's write down about the transmission control protocol. Transmission control protocol establish a connection between sender and receiver using a process called handshake. So it will create a connection first. So that's what you will see here. So before you send, you make the connection here. So the first two line you will see here, it's making the connection. So you have to remember. So this is connection base, and UDP, it's sometimes called connectionless because you will not, make any connection. You just request data. Once, once the connection established, can send data to the other. Once when data is sent by the sender, receiver should confirm. Confirm whether it has received the data. So you have to tell. Now sender will send the packets and wait. So whenever receiver confirms it, then only resend the other, send the other one. Right? If data is lost during transmission, it will be reset, right? So applications, email, and web browsing. හරි පුතේ. මට මිනිත්තු 10ක් විතර දෙනවද පුතේ? අපි දෙකට පටන් ගමු ඊටු ටික.
හරි සර්.
In this section, we are going to look at some application on the internet, right? So basically, we are going to look at why do we need IP addresses, how domain name system will translate URLs, our web addresses to IP addresses. And then we will also going to look at hierarchical and distributed structure of DNS and GET and response in HTTP. And then finally, we are going to look at client server model, right? So basically, we mainly going to focus on domain name system, especially we will discuss whenever you type a URL to computer understand, we should provide the IP address. So that's what DNS, domain name system, does. And then we discuss IP addresses is very hard for us to remember. So we need some ways of identifying these addresses. And then because of that, we have some way of naming the addresses. So we basically know when, for example, when we get an domain name, so we have ends usually .edu, .net, .org, .com, and so on. We know that in the type of the web address, right? Okay, and then we also look at top level domains, and then we will look at client server model. What do you mean by clients? What are the type of servers available, right? So that's the section 6.9. So let's start our first one. Let's write down the topic. Applications on the internet. Now, first of all, let's look at DNS. Right? So let's look at what DNS is. Let's write the first one. Domain name system, or short we call DNS. So what DNS does? DNS, we can say, translates domain names. Example, www.google.com to to IP addresses. So let me show you how we are going to do this. Now, if I going to show my screen, I'm going to use command line. And if I type ping www.google.com, this ping command we use to check the connection to the google.com. So google.com is what we use to remember the Google services, but for the computer needs to convert it. Now you see here, right? So we get the reply using the IP address. So we have IP address here, which actually use. So what happens in the DNS when you want to connect to a domain name like google.com, you need to convert into IP address. Like in our case, it's 172.217.194.103. Right. So that's what domain servers does. Right. So domain name system or DNS, I told you, which will take the domain names, now in our case, google.com, into IP addresses. So the idea is now computer can connect because computer needs IP addresses to look up the places. Right. So let's write down let's draw a small figure on how this happened. Right. So how this DNS works. So we have a sender or the user, and then user request it. Right. We'll draw. Right. We need to have the user. So let me insert some symbols. Let's see more symbols. Can we find out any users? Okay, we have machine, so I will take this one. Computer. I need, so I need a server for this. Right. So I will take a user. I'm getting from the internet. So I take a copy. So now this is my user, right? And then let's have a server. So let's have a server. So now what happened? The communication, right? So I will put part. So I will have, right? So this is my server. This is the user. Now what happens here? We know that they can communicate. Now here it will communicate. So it will communicate. Right? And it will acknowledge. So both ways. Right? Now what user send, I told you, is the web address. I'm going to say www.google.com. So this is what you are going to communicate. And this is right. And what the server reply us with the IP address. So what happens here? We will then the server will say, okay, 172.217, 194, and 103. So reply like this, right? So here is the user, right? So we have the user here. He is the one is going to connect to the Google. And then we have server here. And this is actually DNS server. Okay, so let's take down this. And this is what will happen, right? Communication. Now we have to go to Google. Now this is what will happen. you get the IP address. The next step is, once you have the IP address, then you request the content. So let's take Google. So now let's say this is the our website, Google. Right. Now you get the number. So once you do that, you request the information. Now you get the IP address from the DNS server. So this is the DNS, and here is the user, right? And then from here, it's have another 2 lines. Right? Then you have the second communication. So when it comes to this, what will happen? You request the details. Request content using IP. So you request the content using the IP address, and then, right, website will send the content to the user. So the next one, what happens? It will send the content. Right. Right. So this is what you need to, take down. Please take down the figure. So this is exactly what will happen. So the first one, when you type the URL, it will contact the DNS server. DNS server will give us the IP address, and using the IP address, then we are going to request the content from the website. So maybe we can say website. So here is a website. So in our case, it's google.com, right? So let's take down this, and after that, we will continue. When you get a URL, when you type the URL in the browser, through that you request the IP address using the DNS server. So what DNS does, it will convert the URL into IP address, and using the URL, you request the content from the web server, right? Or you can say website, right? Then website will send the content, right? I think the web server would be the best one. So I'm going to change here, server, web server. We say web server here, right? Web server will send the content, right? Okay. So that's about the domain name system, right? The next I'm going to talk about domain names. Domain names. So let's write down under the domain name. You already know it's a web address, right? And we use domain names to identify computers, right, on the internet. And you have several labels. We'll take www.example, www.pdn.ac.lk, right? And we know LK is the top level domain here, right? LK is top level domain. Then we have second level domain. It's a subdomain. Then we have domain name, right? So if I put some arrows here, right, to indicate. So here is the domain name, PDN is the domain name, and AC is the second domain name, right? AC is the second domain name, right? And then .lk is the top level domain, right? So this is the top level domain. Right. I hope it's clear to you. If you're not really sure, maybe I can increase the font size. Right. So this is the PDN part, and this is .lk, and this is AC. So if you want, I can use couple of colors as well. Maybe, right, I will use blue is the top level domain. Right. So this is, let's say, green is the second level domain, and PDN, right? That's the domain name. Right. So each of these will indicate what those are, like .lk is stand for Sri Lanka, and AC for academic institutes, and PDN for Peradeniya. So let's write down some of the domains examples. Top level domains. Automatically agni varad. Top level domain the vitradati. Right. Putih make udah clearly varai nih. So let's talk about hypertext transfer, or we say HTTP. Let's write down. HTTP is used for transmitting transmitting hypertext documents. So this is used to communicate between web browsers and web servers. Right. So that's about the HTTP, hypertext transfer protocol. That's enough. Right. Then we will write about client server model. Let's write down client and server. Right. So client server means in the internet, there are two types of computers, clients and servers, right? Client server means those who use any services, we call clients. Now, for example, when we want to search information on the web, we use some search engine to do this. And we known as clients. And then requested information come from some other machine that is called servers. So it will serve web pages. It may serve mails, files, and so on. Let's write down. There are two types of computers can be seen in the internet. That is clients and servers. Clients request services from the server computers. Example, web server provides web pages. Email servers provides emails. And file server provide various files. There are different types of servers are there, right? Clients request services. Therefore, servers are responsible for providing various services. Okay, so I hope it now you can understand what server computation means. Right. So let me know if you finish writing down this one. We'll go to the next one. හරිද පුතේ ලියාගෙන?